This video is going to cover adding, subtracting rational expressions with like and unlike denominators. Basically, I've covered everything already in previous videos. This video is basically just going to be going over some problems, some more examples. So there should be 8 of them. Okay, this could be a rather long video depending upon how much material you actually need help with, and so on and so forth. Fast forward through for problems that you need help with. If you don't need help with some of them, then just fast forward and go to ones that you do. But I'm just going to kind of whip right through them. But pause the video before I actually go through them. See if you can do them, and then make sure the answer's right, and you're good to go. Okay, so here we go. Common denominator is already 56b. So because it's already 56b, that means I can just go right from there. So 56b. Now my numerator is going to be a minus 5b plus that 7a at the beginning. Combined like terms, I get 8a minus 5b over 56b. Nothing can be simplified because I have a monomial in the denominator, a binomial in the numerator. Nothing can be made smaller in the numerator, so this is my final answer. Again, pause the video, try to do this one first. Common denominator is already here, 56mn. So I can rewrite that there. My numerator is m plus 2n, right, stays the same, plus 5m minus 8n. Okay, again, make sure we know that that gets distributed through. So combine like terms up top, I get 6m, I get minus 6n over 56mn. Okay, well, my numerator up here can actually be simplified. I can take out a 6, and I get m minus n over my 56mn. Now, the 6 and the 56mn are both monomials. I can simplify those. I can divide them both by 2. So this becomes a 3, this becomes a 28. So my answer is 3 times m minus n over 28mn. Again, pause the video, try it, and then press play. So common denominator. I don't have one, so I need to find one. So I get 5u over 5v squared, and I get 5v over 6u. So remember, with a monomial, I have to look for the numbers first. So 5 and 6, what's number can they both go into? That's preferably the smallest. Well, that's 30. They both can go into 30. And then because I have a v up here, v squared, and I do not have a v down here, I know I have the v squared in my common denominator. And the same thing with a u. I have a u here, but no u here, so my u is down there as well. What did I multiply from that 5v squared to 30v squared u? I multiplied by a 6u. So I got to multiply this by a 6u. That's 30u squared. What did I multiply the 6u to get 30v squared u? I multiplied by 5v squared. So I got to multiply this by 5v squared. That gives me 25v to the 3rd power. Now let's kind of add them together. 30u squared over 30v squared u minus 25v to the 3rd over 30v squared u equals, my denominator is 30v squared u. I get 30u squared minus 25v to the 3rd. But if I look up here, binomial, I can simplify them. I can divide them all by 5. So when I divide it by 5, I get 5 times 6u squared minus 5v to the 3rd over 30v squared u. Monomial over monomial, I can reduce. Divide them by 5. So my answer is going to be 6u squared minus 5v to the 3rd over 6v squared u. Because my denominator is a monomial, numerator is a binomial that cannot be factored further, I am done. This one here, again, pause the video, try it, and then press play. Common denominator is 5 over 5x 5y over 3y squared. Okay, so what is my common denominator? If I look at my numbers, 5 and 3, they both can go into 15. Well, I have an x and then a y squared. Remember, we've talked about that. If I only have one of the variables, so y squared, I only have them one time, it only appears here, then it has to be in both of them. This x only appears here, so it has to be in both of them. What did I multiply 3y to get 15x, or 3y squared to get 15xy squared? I multiplied by 5x. So I got to multiply this by 5x. So that's 25xy. What did I multiply 5x to get 15xy squared? 3y squared. That means I got to multiply by 3y squared up top. That's 15y squared. Now let's kind of put it together. 15y squared over 15xy squared plus 25xy over 15xy squared equals 15xy squared is in my denominator, right, because of common ones. My numerator, 15y squared plus 25xy. My numerator can be factored. I can divide them both by 5, and then I can take out one y. If you think about it, they both contain at least one y. So what am I left with? 3y plus 5x over 15xy squared. That is a monomial. I can simplify my 5 and 15. This becomes a 3. And then I have one y here, but then I have 2 in the bottom, so really that one of them goes away, so I'm left with just one of them. So my final answer is 3y plus 5x over 3xy. Okay, again, pause the video, try this particular problem, see what you end up with, and then press play, and then we can figure out if you're right. So remember, we have a trinomial and a trinomial. If you look at them, both the trinomials are exactly the same, but that's not what I want. Remember, I've talked about making sure we factor first. So both of these trinomials, since they're both the same, I'm only going to do one of them because it works for both. I can take out a 4. That gives me v squared plus 4v plus 3. Remember, they're the same, so they're both that equivalent factored form. Now, this particular trinomial, I can factor 3, 4, 3, 1. So it's 4 times v plus 3 times v plus 1. If you go back to when we learned how to factor. So my expressions, my fractions, are going to be 2v over my factored form, which is 4 times v plus 3 times v plus 1, plus the 2 over the same factored form, v plus 3 times v plus 1. Now let's add the numerators together. I get 2v plus 2 over 4 times v plus 3, v plus 1. But my numerator is not factored. I can pull out a 2. I'm left with 2 times v plus 1 over 4 times v plus 3 and v plus 1. Well, now if I look at it, my monomials here can be all divided by 2. So this goes away, this becomes a 2. Now if I look at my binomials, do I have the same binomial on top and on the bottom? Heck yeah, I do. This v plus 1 and that v plus 1 are gone. So my answer, my denominator is going to be 2 times v plus 3, because that's what's left. But my numerator, I don't have anything left. Well, when I don't have anything left, it's a 1. Okay? The reason why it's a 1 is because technically there's a 1 here and there's a 1 there. 1 times 1 is 1. Let's look at this one here. Again, press pause, do the problem, and then press play to see if you're right. I want to make sure I fully factor. Okay? So can I factor anything? Yes, I can. I can divide them by 6. 6 times 3r plus 4. Both of them are the same, so they're both going to equal that. So I get r minus 3 over 6 times 3r plus 4 plus r minus 3 over 6 times 3r plus 4. So now let's add. My denominator is going to be 6 times 3r plus 4. My numerator is r plus r is 2r. Negative 3 plus negative 3 is negative 6. This can be factored to 2 times r minus 3 over 6 times 3r plus 4. My monomials can simplify. Divide them by 2. That gives me a 3. So my answer is r minus 3 over 3 times 3r plus 4. Again, press pause, try to figure it out, and then hit play. These two, you notice my denominators are not the same. I have a binomial and another binomial. So I have a 5 over n plus 2, and I have a 4 over n minus 3. I want to find a common denominator. You'll notice that they're both binomials. Since they're both binomials, I need to make sure that they're exactly the same. Since this binomial only appears there, that means that that is also in my common denominator. Since n minus 3 only appears there, it's also in my denominator. So how did I go from n plus 2 to my new denominator? I multiplied by n minus 3. And I distribute, so that's 5n minus 15. How did I go from n minus 3 to my new denominator? I multiplied by n plus 2. So when I distribute, I get 4n plus 8. So now let's rewrite this a little bit. 5n minus 15 over my denominator, which is n plus 2, n minus 3, plus my 4n plus 8 over n plus 2, n minus 3, equals, now combine like terms, add stuff together, 9n minus 7 over n plus 2, n minus 3. Now if you actually look at it, my numerator cannot be factored at all. 9 and 7 have nothing in common. So because of that, I know that I cannot simplify at all, so my answer is there. This will be the last problem in this particular video. Again, pause it and then press play to find out if you got it right. Because I have different denominators, I need to find the same one, common one. So I have m plus 1 over m squared plus 5m plus 6. And then I have a 6m and a 3. Well, because this is a trinomial, that actually can be written, I'm going to skip a step here, that actually can be written as m plus 3, m plus 2. Remember, use your x to factor it out. Well, this just stays the same, right? Now let's look. Now I need a common denominator. How do I do that? Well, I have a monomial here. That monomial is the only one that I have, so I have to have that in all of them. This binomial is the only one, and this binomial is also the only one, so I know that I have to have both of them in my denominator as well. So now how did I go from this 3 to all of that? Well, I multiplied by m plus 3 and m plus 2. So I have to multiply this by m plus 3 and m plus 2. I'll do that here in a little bit. Then how did I go from m plus 3, m plus 2 to 3 times m plus 3, m plus 2? I multiplied by 3. So when I distribute, I get 3m plus 3. So now let's figure out what my numerator is here after I multiply all of that stuff together. Well, it's the 6m still, right, from over here, times, I'm going to multiply m plus 3 and m plus 2 out. You can use a box. I'm just going to do it real quick. It's m squared plus 5m plus 6. That gets multiplied by the 6m. That's out front. So I get 6m to the 3 plus 30m squared plus 30m. And that's over 3 times m plus 3, m plus 2. And this is 3m plus 1, plus 3 over m plus 3 and then m plus 2 into 3 out front. So now let's add those together. So I get 3m plus 3 over 3 times m plus 3, m plus 2 plus the 6m to the 3 plus 30m squared plus 30m over that same denominator. So now let's add. I get 6m to the 3 plus 30m squared plus 33m plus 3 over 3 times m plus 3 m plus 2. I'm not done yet because my numerator can be factored. I can divide them all by 3. I get 3 times 2m to the 3 plus 10m squared plus 11m plus 1 over 3 times m plus 3 m plus 2. So what can I do? Well, I have a monomial. They're both the same, so they can get canceled out. But if I look, I have a 4-term polynomial up top, and I have 2 binomials in the bottom. We cannot factor any of that out, so therefore I am done. So let me just rewrite it. I get 2m to the 3 plus 10m squared plus 11m plus 1 over m plus 3 m plus 2. And that's your final answer. This concludes this video. This is just a video based on just extra practice. So if you need help with how to actually do it, watch the videos where it talks about how to do it. This is just going over some examples.